Hello, Internet. Welcome to part 4 of the series, Create Interactive Multisensory Experiences with TouchDesigner and Playtron. In this video, we'll focus on building a network designed to create various interaction logics. As many of you know, the main inspiration behind this series is to equip you with diverse skills for developing interactive installations. This is why I have chosen to use Playtron as the trigger for the entire series. However, for logistical reasons, if you do not have access to Playtron, this video will demonstrate using keyboard input instead. Keep in mind, though, that you can easily substitute this with any MIDI controller. Before we begin, I'd like to ask for a big favor. As you know, this channel has grown from 100 subscribers, and we're now approaching 10,000. This growth benefits everyone. More subscribers mean more opportunities for me to create better tutorials and content, and for you, it means access to even more in-depth knowledge about TouchDesigner. To keep this momentum going, remember that subscribing to the channel helps us all continue improving and bringing even more valuable content. Thank you for your support. Chapter 1. Create an interactive network. Very well, up to this point we are doing great, right? For the second part, before creating the next networks, let's review a few details. Every time I change a point cloud, I can see this error occurring. All instances must be the same, and this happens because not all my point clouds were imported with the same number of points, which gives us a different resolution for each file. So, if we observe, there are differences resolution for each file. First, we create an info chop to see what resolutions we have depending on which operators we have passed through. Then we can drag this switch to the first info, and this one to the second. Select only this parameters. For monitoring, only the resolution values. Now, I'll switch between each point cloud, and I see that the resolutions change. They are the same for both positions and colors. But the problem is that the feedback retains the previous resolution values until it is reset, which will always create this issue. To solve this, remember we created a master node at the beginning of the part 1 of this tutorial. If you have just joined this video without watching the first part, I recommend you go back and watch the first video. In this constant operator, we'll set an average resolution of 520 for both X and Y. Then select all the point clouds. We'll set a custom resolution and map these corresponding values to X and Y. Now, if we go back to the info, we see that the values remain the same and the error disappears. So far, so good. Let's continue now with some network details that I want you to notice. Before getting into the more complex part of this tutorial, let's add some details. Do you remember the spheres we have here? When did I show you the result of the tutorial? This is quite simple. Just follow these steps. First, create a sphere SOP, followed by a transform, and then add a material operator. Finally, create a Phong material and drag it inside the material. We'll create a GEO, and with that, our spheres are done. Later, I'll show you which instances will align the spheres with certain coordinates of the point cloud. It is important to mention that I will not use all the coordinates to clone the spheres. Instead, I will limit the instances to using a reduced number of coordinates. Next, we'll create a Box SOP. We'll place it here, followed by another transform, which is quite similar than the previous network. Also create a material operator. I'll use a wireframe material for the box, and another geo. Perfect. Let's first configure the box parameters, selecting it and copying these settings. Set the box dimensions of 15 by 15, leaving Z-axis at 0. In transform, we'll choose the position we want for this box, setting it to -10. You can see it below, and in the wireframe option, select topology wireframe to visualize the grid. Then, go back to the box and select subdivisions of 3 by 3 by 3. You can increase the scale and transform if desired. And I will set the subdivisions of the box to 5 by 5. Okay, this looks good. Now, with the sphere, it's a bit different. For the sphere, we'll use the following network, as I want it to repeat at certain coordinates for each cluster, but not all of them. Before creating this network, select the sphere and ensure we have the correct size. Go to Transform, and you may set it to 0.25 for a smaller sphere. It's important to select the polygon mode for the sphere, as we want to reduce computational resources. 3 segments should be fine. For now, that's it for the sphere. The network above is quite simple. We'll create a select top, followed by a resolution operator, then a match operator, and finally a null. We'll name this null sphere position. Let's tidy up the network and duplicate it below, renaming the last null to sphere colors. Perfect. Now, what do I want to achieve? I essentially want the same coordinate values I'm using in the point clouds. This is why I'll drag the first switch to the first select and the second switch to the second select. Now, I have these values. In the resolution, remember that we have our master node. We'll select both resolutions, set custom resolution, and map these values here. So we'll map X and Y and set, for example, a value of 10. Now, I have a resolution where I've simplified the coordinates to 10 positions, which are, of course, randomly selected. Remember that we created a math node for this position range. We'll set it from 0 to 1. In this second math node, we can manipulate colors, just as we did at the beginning of the tutorial. So I'll use these values for now, and I can see that the colors become more visible. Now, we are going to reference the positions of the sphere that we are extracting from the point cloud file within the instances of the geo. Turn on the instances. Position coordinates will go into the translate and select RGB as appropriate. Perfect. Now, you can see that the spheres appear here in black, and if we move to the second instance, we go to the color operator and select RGB again. Perfect. The colors won't appear until we change the material settings. Go to Fong. Select a white color in Emit to make them visible. And now the colors appear assigned to the coordinate positions. You can see, for example, a blue, gray, or white sphere. Now, what's important is that this map here lets you decide if the positions will be more open or closed. Additionally, if you want to change the global value of the sphere, you can do so in Transform operator. Now, let's focus on the interactive part. I was planning to teach you this entire network using MIDI in for use with Playtron. However, since I know many of you don't have the device, I think it will be easier to create it with a keyboard in, which you can later replace with values from any MIDI controller, such as Playtron. This way, everyone can follow the tutorial, whether they have a MIDI controller or not. If you do, simply replace the keyboard input with MIDI control. I'll use keys 6, 7, 8, and 9. We'll add a select node first, and the first thing I want to do is control the switch, which remembers we have a switch here that selects between the 4 point cloud files we have. In the select node, we'll connect a count operator, followed by a lag, and finally, create a null node. Remember, pressing Alt plus N creates a null automatically. I will name this null master switch. Perfect. With this, if I press key 6, I see it activates. I'll select only key 6 in the select node and go to count. I want it to count from 0 to 3, which are the index values of the switch. The switch ranges from 0 to 3, where 0 represents the first point and 3 represents the last one. Now, I need to map these values. I'll leave the lag node as is. Select both switches. Reference this value from here. There may have been something previously set here, but ignore that for now. Enable the blend between inputs, because I added a lag node as I want a smooth transition between inputs. So when I press key 6, you'll see this effect happening. Perfect. Now, it's crucial to reset the feedback so that we can view our shape in its original form. To achieve this, we'll create a simple logic where every time I press key 6, the feedback resets. To do this, let's connect a null node here. What I want to do is that each time I press key 6 in operation is sent to reset the feedback, but with a delay of around half a second. I'll create a timer node here, connect it to a null, and named reset feedback. So what this key 6 does is essentially initialize the timer. So you need to reference the key to the start parameter. The timer works in seconds and will last half a second or even less, let's say 0.25 seconds. When I press key 6, the timer starts, counts for 0.25 seconds, and when it finishes, it will send a signal to the feedback to reset. Optionally, you could place a select node here to choose only this option, and we'll use reset feedback to send signals to both feedback nodes. Select both, go to the feedback section, and reference this last, values it with the key we previously had. Now, when you press key 6, you'll see it automatically changes and then resets the feedback almost instantly. If it responds too quickly or too slowly, you can adjust the timer's duration, such as setting it to 0.5 seconds, and find the point where the feedback operates optimally. If it's too slow, try experimenting with other settings to observe the impact. Okay, for the second key, let's create another select node and duplicate these elements. Here, we'll use key 7. I want this to produce a glitchy kind effect, scattering all particles in some direction. To achieve this, go to the noise, and by manipulating the noise scale, for instance, setting it to 100, we can stretch or modify the shape of the particles. In this example, I'm focusing on the scale Z parameter. Next, in the select node, create a lag operator, then connect a math operator. And finally add a null and rename it to noise Z. Remember, using a lag node means values can range from 0 to 1. However, with strong interpolation, those values might not reach 1 completely. Let's test it by pressing key 7. We almost reach 1. I'll map these values from 0 to 0.9, for instance, and adjust them from 1 to something extreme like 500. We'll map this to our noise settings. Pressing key 7 triggers this effect. Additionally, we can add transformations to the x-axis, generating more lines look. Now, I notice the effect is quite exaggerated, so I'm going to reduce this parameter. If you'd like, we can leave it at 1 with an output range from 1 to 10. Let's reset the feedback and observe the result. What I'd like to do next is create thinner lines. To achieve this, I'm going to go to my point sprite, select the constant point scale, and set it to 1 or maybe 2. Much better. Let's move on to the next interaction. I will use the 8 key. What I want this next to do is a bit more difficult, and you will need a specific operator that you can find for free on my Patreon, but basically what I want is to have 4 or 5 different camera's angles positions. Again, I will use this select chop and create a count operator. I will probably record 4 different angles, so I'll set it from 0 to 3. Finally, create a null and call it switch camera. Now, for this, I have a free component. I'll show you how it is used, and it is available on my Patreon. Here we have the camera, right? Go to your components, drag in this component called Save the Cam. What this component does is save the different camera positions we have. Go to Reset, clear everything. I'm going to select a camera position that seems interesting to me. For example, that one. Go to Presets and click Save, and now it is recorded in position 0. I select another position. Save. Now it is in position 1. Here I can check. This is 0. This is 1. I'll record another position. Save. I have 0. I have 1. I have 2, maybe one more close-up. Save. And 1 here. You can really play around as you wish, and save. So, now I have 0, 1, 2, and 3. An error I just noticed. The position corresponding to index 0 will always result in the initial coordinates of the camera, meaning the default ones. Therefore, if we want to avoid this position, we will need to start from index 1 onwards. So let's double check that we have 4 positions recorded. Perfect. But here comes the interesting part. I really want there to be a smooth transition between the coordinates of the camera movement. So if I simply switch from 1 to 4, there is no transition. The change is direct, right? What I can do is pull out a null here, and I see that here I have all the camera positions I recorded, right? I create a lag. I can directly delete this null and create another null here and call it camera 2. Then I'm going to create a new camera. I will put it here and reference all these values to the coordinates of my camera. So let's go with the coordinates X, Y, and Z. Let's go with the rotation coordinates X and Y rotation Z. Perfect. Let's go with the scale in X, Y, and Z. Finally with the pivot point, X, Y, and Z. I can increase the lag values to 0.5 for each parameter. Then you can use the option lag magnitude and set the values at 0.2. Now, I tell the render top to look at camera 2, and with that we already have this type of camera motion. It's super interesting and easy to use. You can leave camera 1 there, or you can turn it off or delete it, whatever you want. So simply remember that we are using 1 to 4, so we change the counter to this values, then reference our switch camera to the index of the custom component. Now with key 8, I change the camera. Key 7, I create this glitch effect. And with key 1, I switch between point clouds. We are now very close to the final result. My goal is to add a touch of motion blur, like effect to the camera movement, which requires creating a feedback system. Let's move on to this next step. We'll insert a feedback here. Followed by a level node. Many of you are probably familiar with this setup. Then, create an add operator and connect everything accordingly, with the last operator referencing the feedback. In the level node, under the Post tab, you'll find the opacity settings, where you can adjust for greater or lesser feedback effect based on the values you choose. What I want is for the feedback to activate every time key 8 is triggered. To achieve this, we'll create a null here. Then, all we need to do is add a math operator, and, finally, another null, which we'll name camera feedback. For the math operator, we'll initially set it to go from 0 to 1. We'll fine-tune the exact values later. Additionally, let's insert a lag operator before the math node to ensure a smoother transition and motion. Now, let's proceed with mapping this and see how it feels overall. Select the level operator and map the opacity value. By default, it is set to 0, but when I press key 8, you'll notice that it activates feedback, creating even more movement. This is quite interesting. I think it could be a bit slower. So let's adjust the lag values to 0.4 by 0.4. Remember, you can fine-tune this further. It can even be slower if necessary. Perhaps try 0.5 by 0.5. We'll leave it at that for now. The effect of the feedback will vary depending on how long we hold the button, creating a stronger or subtler impact. Perfect. At this stage, we have almost everything we want to achieve. There's just one more detail to address. For these tiny spheres, I want to introduce a noise effect on their scale, so that each sphere will have a different size. To do this, I'll create a noise operator, then duplicate it. Next, I'll set up a switch and connect both noise operators to it. Finally, I'll create a null, which I'll name sphere size. Remember that I'm using a resolution of 10 by 10, so I'll copy this and paste it directly into my resolution settings to maintain consistency. With this setup, I can ensure that the instances behave as expected and nothing goes wrong. I'll go to the Geo component of the spheres and navigate to the Instances section where I'll locate the scale settings. I'll select RGB as usual, and now I can see that all the spheres have different sizes. You can experiment with the noise values to customize this effect, but for now, it works quite well for my needs. Since I have a switch that I want to transition to the second noise, whenever a specific trigger is activated, I'll modify this noise under the transform settings. I'll use the classic expression abst time.seconds, divide it by 15, or alternatively, leave it at 2 for a slightly faster variation. I will control this switch using the last of my keys. So, I'll select the next key, which is 9. I'll create a simple null, since this key will only toggle the switch on or off. Rename the null as sphere switch, and finally reference this null to the last switch we created to toggle between the static noise and the animated noise. You'll see that the spheres change randomly on the screen. If I press key 8 to switch the camera, it allows me to observe this change more clearly. The next step involves making a few tweaks, adjustments, and ensuring everything looks a bit more captivating. So up to this point, we are done. It's important to review certain parameters, and I believe this will depend on individual preference. Chapter 2, Tweaks. At the moment, what stands out to me is that when switching to a more neutral camera view and transitioning from one point cloud to another, there's excessive noise, right? This occurs because the switch is blending values. To address this, I can disable it and test again to see the result. I also notice some interpolation due to the lag we're using. I will temporarily turn off the lag operator to see the result. You can also test with smaller values. Also remember that if we navigate to the threshold and set it to luminance, and then reset the scene, it behaves differently than when set to green or blue. This opens up some interesting possibilities. We can use the same camera counter to change the different color options available in the threshold. We can reference this same count to the threshold, resulting in different positions, making the outcome even more engaging. And another thing to keep in mind is that the second noise operator and the threshold are among the most critical elements you can utilize for creative control. For instance, if I lower the amplitude on this noise and reset, we can observe subtle particle movement. When moving the camera, this motion appears slower compared to before. Increasing the amplitude significantly, let's say to 10, causes particles to spread across the entire space. Leaving it at 3 creates a particle explosion effect. Very captivating. But the choice depends entirely on your preference. For now, I'll set it to 1. Additionally, the exponent can adjust the particle's motion, making it more or less intense. Higher values can condense particles into a tighter cluster, whereas lower values create a more dispersed effect. If I want the camera to rotate constantly, go to the camera and select the Pre-Xform Options tab, and turn on the Apply Pre-Transform option, and use the classic expression abstime.seconds. Now, I have continuous camera rotation, alongside previously created camera movement. Regarding audio synchronization, instead of a tutorial, I'll explain it with the final file. Chapter 3, Sync Audio Review. I want to mention that we won't be going into the specific structure of the audio right now. However, I brought this file, which was the original file used to create this entire project, and you can find it on my Patreon. It's important to note that all audio files and point cloud files will be included in the package, allowing you to open and use the document without any issues. So, let's go over a quick review. This time I already have a Playtron device connected, which you can see through the webcam. Remember, Playtron can connect to any organic surface: fruits, foods, humans, plants. If you're curious to learn more about Playtron, I highly recommend watching the first tutorial in this series. This video is the 4th in the series and complements the previous video. So if you're feeling a bit lost, I strongly suggest checking out the 3rd video. In that one, I explain step by step how to create interactive and multimedia experiences using TouchDesigner and Playtron. Alright, let me walk you through what I've done so far. First, keep in mind that this network is what we covered in the previous chapter. The main difference is that this time, I won't be using the keyboard as an input, but rather the Playtron MIDI. For instance, let's examine each of the buttons. I'll make contact here, and this button changes the camera's position. Another button controls the tiny spheres. And finally, we have a button that handles the glitch effect. When all 4 are combined, you can begin to tell a story. Of course, the type of interaction can be adjusted based on the narrative you want to convey. There is a background audio track that I can activate so you can hear it. I have various triggers, such as for camera movement. These triggers are tied to 4 different sounds, all organized within a switch that is controlled by the same operator managing the camera switch. The logic is straightforward, and the same approach is applied to other sounds, all of which are controlled through the previously mapped controls. If you want to learn more about this or have additional questions about audio manipulation, feel free to leave in the comments. One of my preferred methods, depending on the project, is synchronizing with Ableton Live. In fact, I'm planning a course called Mastering Audio Reactive Techniques. While the simplest method is what we're covering now, we'll delve into more complex approaches, syncing with live, separating music tracks, drum sounds, and vocals, assigning distinct effects and triggers. It will be more challenging, but highly engaging, and I plan to explore this further by 2025. Many of you may be wondering how I made the audio react in terms of amplitude. This was achieved by assigning a modulator to the size of the particles, simulating a response to sound. While unconventional, understanding how to emulate certain sound frequency responses using mathematical algorithms can be very powerful. Finally, there are 2 more audios in this composition. One is synchronized with the glitch effect, and the other is tied to the spheres with random sizes. That's essentially everything. I hope you managed to follow along without any issues. The possibilities are truly limitless, as you can create any type of point cloud using this technique, even incorporating AI. I highly recommend visiting my Patreon, downloading the project, dissecting it, studying it, and discovering what more you can contribute and create. Don't forget to subscribe to the channel, and I'll see you in the next video.